In this video, we are asked to do a definite integral of the function x squared times absolute function of x minus 3. We integrate from x equals to 0 to x equals to 4. Before we integrate a function with an absolute function, we need to remove or change the absolute function to its equivalent forms. To do that, we need to study the absolute function of x minus 3 in this case. Now we know that if we look at the graph of absolute function x minus 3, when x is bigger than 3, for this portion that I'm highlighting in blue here, the equation of this arm of the absolute function is y equals to x minus 3 because it has a positive gradient. The other arm for x less than 3, if I were to highlight this portion in red here, we know that this red portion came from the reflection of the line y equals to x minus 3. As you recall, when a graph is reflected in the x-axis, we put a negative sign in front of its function. So for the red portion, because it's the reflected portion, the equation is y equals to negative of x minus 3. So we know that when x is less than 3, your y is equal to negative of x minus 3. But for x more than or equals to 3, your y equals to x minus 3. So we use this knowledge to simplify the integral, breaking it into two parts that involve the equivalent forms of the absolute of x minus 3. So instead of integrating from 0 to 4, we need to break it up at x equals to 3. So we integrate for x equals to 0 to x equals to 3. We copy down the function x squared. For x equals to 0 to x equals to 3, the function absolute of x minus 3 follows the equivalent form of negative of x minus 3, because the values of x in this integral will form x equals to 0 to x equals to 3. So that corresponds to the portion when x is smaller than 3. Next, we write down the integral for value from 3 to 4. We again write down the x squared as in given in the original integral, but we know the absolute of x minus 3 will follow the equivalent form of just simply x minus 3 without the negative sign. So we have this is equivalent to the next line in our printed solution here. So when we simplify these expressions and we integrate and evaluate the integral, we get 27 over 2. This example is not in your lecture book, so you will need to write it down in the notes page of a lecture book. In general, if we are required to integrate the absolute function of fx for values of x from a to b, we always analyze the graph of fx, that is the function without the absolute sign, and consider refracting the negative y portion in the x-axis, calling it y equals to negative fx. Next, analyze the values for which the fx equals to 0, let's say c to d, and break up the original integral into various integrals according to what you see from the graph. So for example, if, let's say, A is between C and D and B is greater than D, definite integral refers to area under the graph bounded by the graph and the x-axis. We will understand that the area described by the integral is this portion. So we will break it up into integration from A to D, and for this portion, because the area is the refracted portion, we will put negative fx dx, and for values of x between D and B, we know the portion of the graph involved has the equation y equals to fx. So when we remove the absolute function, it will still be fx, and we will integrate accordingly. I hope this clarifies the picture. Thank you for watching this video. Bye.